Now, we'll take up one more problem. The problem number 72. A bar of cross-section 10 mm by 10 mm is subjected to an axial pull of 8,000 Newton. The lateral dimensions of the bar is found to be changed to 9.9985 mm by 9.9985 mm. If the modulus of rigidity of the material is 0.8 into 10 to the power of 5 Newton per mm square, determine Poisson's ratio and modulus of elasticity. So what is this longitudinal stress? So first we're going to take up the longitudinal stress, sigma. So how sigma will be equal to P by A. So P is, that is 8,000 divided by 10 into 10, that is the cross-sectional area, that is original cross-sectional area. So on simplification, you will going to get it as 80 Newton per mm square. So what is the lateral strain? What is the lateral strain? Which is sigma by m into E, because Poisson's ratio is 1 by m is equal to lateral by longitudinal. So what is the lateral strain? 1 by m into longitudinal strain. What is longitudinal strain? Longitudinal strain epsilon will be equal to sigma by E. So that is the reason why you are getting this sigma by m into E. So that will be equal to sigma, we know 80 by m into E. So we don't know the value of Poisson's ratio, that is the one which I need to find out. And modulus of elasticity, which also I don't know. So therefore 80 by m into E. Also we know what is lateral strain, which is delta D by D. So what is delta D? So we have that the lateral dimensions of the bar is found to be changed to 9.9985. So that is 10 minus 9.9985 by 10. So you're going to get the lateral strain, which is 1.5 into 10 to the power of minus 4. So we know, now we got the lateral strain. So 80 by m into E. So you substitute that here, 1.5 into 10 to the power of minus 4, which is equal to 80 by m into E. Therefore, m into E will be equal to, on simplification, 0.533 into 10 to the power of 6. So, but now we want to find out the Poisson's ratio and also the modulus of elasticity. So ME, we got the total value. So now, what is modulus of rigidity? G will be equal to, we have the expression that is m into E by 2 into m plus 1. So we know the modulus of rigidity, which has been given 0.8 into 10 to the power of 5, which is equal to m into E, which I know 0.5336 for 0.533 into 10 to the power of 6 divided by 2 into m plus 1. On simplification, you are going to get the value of m as 2.33. But what is Poisson's ratio? It is 1 by m. That will be equal to 1 by 2.33. On simplification, you will going to get it as 0.4292. So we got the Poisson's ratio. So but m into E will be equal to 0.533 into 10 to the power of minus 6. So we know the value of m. Therefore, E 2.33 into E. 2.33 into E will be equal to 0.533 into 10 to the power of minus 6. Therefore, Young's modulus E on simplification, when you take that 0.533 into 10 to the power of minus 6 by 2.33, which will be equal to 2.287 into 10 to the power of 5 Newton per mm square. So this is how you will be able to get the answer for both Poisson's ratio and also Young's modulus. Now we are going to consider the last problem, which is 73, the problem number 73. A metallic bar of length 250 mm, width is 30 mm and thickness is 20 mm is subjected to an axial compressive load. So that is 240 kilonewton. The decrease in length is 0.5 and the increase in width is 0.02 mm. Determine the linear strain, the lateral strain, the Poisson's ratio and Young's modulus. So as the compressive load is applied, so along the length it will going to be the decrease in length and the lateral dimension will going to be increased. Therefore, you are going to get it as increase in width. So L is given to be 250 and B is given to be 30 and D is given or T is given to be 20. So P is 240 kilonewton, which is 240 into 10 to the power of 3. So what is delta L? 0.5 and delta B is 0.02. So cross-sectional area, what is that cross-sectional area? 30 into 20 D into T, which will be equal to 600 mm. square. So what is the linear strain? That is the change in length or decrease in length by the original length. So since it is the decrease in length, so that is delta L by L. You know delta L is 0.5 by L is 250. So you're going to get it as 2 into 10 to the power of minus 3, which is unitless because it's strain. So what is the lateral strain? Which is increase in width by original width. So delta B by B. So that is equal to 0.02 by 30. So on simplification, you will going to get it as 6.667 into 10 to the power of minus 4. But we want the Poisson's ratio, which is epsilon lateral by epsilon longitudinal. So that is lateral strain by the longitudinal strain. So epsilon lateral is 6.667 into 10 to the power of minus 4 divided by 2 into 10 to the power of minus 3. So that will be 1 by m will be equal to 0.333 or 0.33. So what is the linear stress, which is axial compressive load by the cross-sectional area? So axial compressive load, which is P by A, which is equal to 240 kilonewton, that is 240 into 10 to the power of 3 by cross-sectional area of the bar, which is 600. On simplification, you will going to get it as 40 Newton per mm square. So what is the Young's modulus, which is linear stress by linear strain, which is sigma by epsilon. So 400 by 2 into 10 to the power of minus 3, which is equal to 200 into 10 to the power of 3 Newton per mm square. So this is how you will be able to solve this particular problem. If you find this video is useful, please subscribe to this channel. Thank you very much.